Hello and welcome back. I hope you all had a chance to stretch your legs because we have a lot of exciting talks coming up. Next, we have John Riviello, who is a fellow and the lead client engineer at Comcast for mobile development and a good friend of mine. In John's current role, he works on the Xfinity native and web applications. He's also a LinkedIn Learning course author and a Google developer expert. In his free time, he prefers surfing waves over surfing the internet, and that sounds good to me. Let's listen in as John discusses the art and science of decision buy-in.
Hi, everyone. So I'm very excited to talk to you today about a topic that I'm sure you and your team members are responsible for in various capacities. And that is an effective way of making important decisions, both big and small. And whenever these decisions present themselves, there's the question of how to decide, what is the process of making that decision and who will decide. So there's a few approaches to this. One is just give that power to the most senior engineer. So usually that's me. At your job, it might be you, but just because I'm the most senior person in the room, that doesn't mean I'm always right, although you might always be right. And everyone's input is valuable. And I wrote a lot more code when I was a junior engineer, and I definitely value the opinions and input of everyone involved, no matter what their level is. Another option is an equal democratic vote. So everyone gets a say, and then the majority wins. This, of course, means that if it's not unanimous, some people are going to be upset. This also brings up the question that perhaps the votes of the more experienced experts should carry more weight than others, which sounds somewhat like a meritocracy-based decision-making process, which also has its own set of issues. There's also this overall concept of wisdom of the crowds to make a decision. So this seemed to work pretty well on Who Wants to Be a Millionaire when the contestant would ask the audience. And there's actually been a great deal of research behind this concept, and it shows that if you take many independent judgments and then merge them to form the best overall decision, that's often found to be more accurate than an expert's individual judgment. There was an article published in the Harvard Business Review a few years ago, and I researched this further and went beyond just the do you get the right answer aspect of the wisdom of the crowds. And in their research, they found some hidden costs to blindly adopting this approach. So to help demonstrate what they found, let's do a little exercise here. So I'm going to ask a question here. This comes from a post on the Google testing blog from a number of years ago. And I'm taking this totally out of context, but it really works well to kind of demonstrate this example. So in the post, presents a situation where a programmer approaches this wise teacher named Testivus, and he says, I'm ready to write some unit tests, so what code coverage should I aim for? And the wise Testivus replies, 80% and no less, pounding his fist on the table. So think about this. What would your reply be if someone asked you this question? Now, the point of the blog post is this answer is much more nuanced. But what happens when someone else's estimate is given first, especially if it's an expert giving their opinion, like the wise Testivus in this case? So this is what the researchers wanted to understand. So what they did was they asked participants to look at someone else's decision first and form an opinion about it. Then they were asked to come up with their own decision. This resulted in something that is known as anchoring. So basically their decisions that they led to were drawn to that initial number that they saw initially. This is a big factor in things like real estate, where the listing price will help drive the final sale value. So the study states that basically when someone forms his or her opinion impacts how they evaluate the opinions of others. If the opinion is presented up front, then this anchoring occurs. And that's not good, especially when we know that from the wisdom of the crowds that is more accurate than even an expert. So what about if we form opinions first before evaluating the opinions of others? So this is essentially the opposite of anchoring, which we just said is a bad thing. But the problem with this approach is this will only work if everyone agrees. More likely, there's going to be disagreement. And while disagreement is not necessarily a bad thing, you want to have diverse judgments. This is a solid foundation for leveraging wisdom of the crowds. In order for disagreement to be effectively leveraged, it first has to be correctly interpreted. So when there's disagreement, that means that at least one, if not both or all parties are wrong, because at least one of them has to be wrong in that case. So in the final study cited by this article on the wisdom of the crowds, they dug into this further. they asked people to make a decision before they saw a decision of another participant that was selected at random from a prior study. So some participants saw peer decisions that were in close agreement with their own, and others saw ones that were much different. Then they asked the participants to evaluate the quality of that peer decision of the other individual versus their own decision. And what the researchers found was that as the disagreement increased, people evaluated others' decisions more harshly, while their own evaluations of their own decisions didn't move at all. So the participants interpret this disagreement to mean that the other person was wrong, but not themselves. So this shows that when forming opinions first, before evaluating the opinions of others, that there's these social costs that come along with that. Participants in the study thought less of the other person's estimates and ideas, and in some cases thought the other person was less ethical and intelligent. So we know we want multiple independent, diverse judgments, but if an opinion is presented up front, we have anchoring that occurs, and then if we wait, we have these social costs. So what do? Is this hopeless? So here's what the study concluded. First, to maximize accuracy, team members should form independent opinions in advance before they come together as a group. This will help avoid the anchoring. Next, groups of decision makers should also pre-commit to a decision strategy so that when they combine their opinions, they know what they're doing in advance, and this can help protect the team from those negative social consequences. And last, and this is kind of a fun one, in quotes, teams facing quantifiable questions should aim for strategies that, as much as possible, try to remove human judgment from that analysis process, which sounds great, but how to go about and actually do that? So I was in a situation a few years ago. I was actually on a team that was building a web application at the time instead of a mobile application. And it became clear that we were going to have to update our JavaScript framework. We had to basically rewrite the application in a new framework. So I explained the situation to my manager, explained why it had to be done. And he said, John, I trust you and I trust the team to make the right decision about which is the right framework here. But how do you know that the process you're going to use to arrive at that decision is effective and actually the best way to go about that? So he asked me to actually go ahead and research how I would make the decision before I would commit to the decision. So I went out there, I ventured onto the internet researching, how to make good decisions. And during that process, I came across a number of academic papers that were looking to answer a question totally unrelated to tech and much larger than anything that I had ever considered in tech. So these papers were focused on what to do if your state or your country needs to build a new power plant. So this is critical infrastructure you're going to live with for the next 40 to 60 years at least. So you do not want to screw up this decision. Do you go with solar power, wind, hydro, nuclear, fossil fuels? Then if you go with nuclear, there's different types of power plants to choose how you want to build that. And in all these papers, the tool that was used to arrive at the answer was something called the Analytic Hierarchy Process. This was created over 40 years ago by this guy right here, Thomas Saati. So why do I like this so much to actually talk to you about it today? So this gives you structure to your decision making, and it removes the emotion from it in the analysis. It also helps to reduce the loudest or the most senior person in the room and helps to determine what's actually best for the group. Again, this has been around for over 40 years, and if it can help make huge decisions like building a power plant, then surely it can help all of us in tech with our silly little decisions we have to make from day to day. So when you read about the analytic hierarchy process, which I'm going to refer to as AHP, because that's much easier to say, there's also this example of choosing the most suitable leader. And the setup for this is that some company, for whatever reason, they need to choose a new leader. And this example works well, but let's have a little more fun than just some company choosing a leader. So let's pretend that we're being transported to some mythical world with dragons, and we're going to help these people choose the new leader. And the contenders to step up and lead these people are, we have Astrid from How to Train Your Dragon, Princess Fiona from Shrek, and Eep Crude from The Crudes. So here's how AHP works. You have three components to it. You have a goal, you have the criteria, and you have what AHP refers to as the alternatives, which are the choices, essentially. So in our case, our goal is going to be choosing the most suitable leader. For our criteria, I've chosen experience, strength, charisma, and integrity. Now, your criteria should be specific to your group and your team's abilities and your situation. These are just the ones that I've chosen here. It's also important that you should have no more than 8 when you're going to do these evaluations, and you'll see why pretty soon. That'll become very clear why 8 is plenty. And then for our alternatives, our choices, as we said, those are Astrid, Fiona, and Eep. So once you have these, you'll start doing what are called pairwise comparisons, which are taking two things and comparing them to each other with respect to something else. And this is how we're going to determine who is best for each criteria. So in this case, we can compare Astrid and Fiona to each other with respect to experience. We can also compare Astrid to Eep and Fiona to Eep. And then we'll do similar pairwise comparisons for strength, for charisma, for integrity. And then to properly weight the criteria, we're going to go through this process as well. So we'll do these pairwise comparisons with respect to the goal. So in this case, it's experience versus strength, strength versus charisma, charisma versus integrity, and so on and so forth, till you've done all these pairwise comparisons among all the alternatives and all the criteria. So let's take a look at what that pairwise comparison process actually looks like in detail. So we'll first take experience and set of pairwise comparisons for our 3 potential new leaders here again, Astrid, Fiona, and Eep. So for each pairwise comparison, you're going to use this scale. Now, there's a lot of text on the slide, which you're welcome to read later. But the important things to know are that if 2 things that are being compared are, for all intents and purposes, equal, then they both get a value of 1. If the 2 things being compared are wildly different and one is extremely more important than the other, then the winner, so to say, in that case, would get a 9, and then the loser gets a 1. There's odd numbers listed here, but even numbers are fine to use as well. And then if something is ever so slightly more than equal, you can use decimals like 1.1, 1.2, 1.3, but once you get into the level of 2 and above, just the whole numbers work well. So let's go through an actual scoring exercise. So again, we're going to evaluate our 3 alternatives with respect to experience here. And we're going to say the first thing you do is everyone compared to themselves is, of course, equal. So those get a 1 in this chart right here. Then we're going to compare Astrid and Fiona. Now we're going to say in this case, Fiona is more experienced than Astrid. So Fiona is the row in this case. We're saying that she's going to get a 4. The level of that is a moderate to strong. She's better, more experienced than Astrid in this case. And then what's going to happen in Astrid's row here with Fiona is she will get the reciprocal of that amount, which is going to be 1/4 in that case. So next we'll say Astrid compared to Eep. We'll say in this case, Astrid is more experienced than Eep, also by a level of 4. And then that means in the bottom left corner there with Eep versus Astrid, there'll be the reciprocal of that. So that'll be again 1/4. Then for Fiona versus Eep, Fiona is clearly more experienced in this case. We're going to give her a 9. And then that means when we're comparing Eep to Fiona, again, the reciprocal of that would be 1/9. So once we have these values, we can calculate what is referred to as the priority for each of these candidates with respect to experience. And this is where some math formulas of HP come into play. So for this data set here, the calculations are what you see right here. And these priority calculations are based on vector math and the principal right A in vector, which I didn't know what that term meant before I learned about AHP. So now I'm going to try to explain that because you really don't need to understand the details of that. Just basically, you need to know that HP uses that and gets to these calculations here. However, if you do enjoy vector math and you like reading math proofs and you know what a principal right A in vector is or want to know, Thomas Otte did write a 6-page research paper explaining why it's necessary. You can find that on the internet with a quick search. Now, I've read that paper multiple times, and the one statement that I've learned from it that I'm going to basically take at face value is it says that human judgment is inconsistent, but the principal right A in vector helps to mitigate that impact. Again, personally, I don't know exactly how that works, but HP has survived 40 years of academic peer reviews, so it's enough proof for me for that. So now that we have these numbers, we can start to plug these into our graph. So we've got our priority numbers right here on the right. We can put them into our graph here for each one of those individual alternatives with respect to experience here in the graph. Now we'll repeat this process for strength, for charisma, for integrity. And then we'll do this again with the criteria with respect to the overall goal. So as we go through that, here's an example of a full table with criteria with respect to the goal. I just plugged in some numbers there, ran the calculations here. You can see the priority values for those on the right. So once we have all this data, we can actually march towards computing our final decision. And the math gets much easier now. It's pretty straightforward. You know, my 4th grade son, the math he's learning right now, definitely sufficient for that. So the way this works is, again, we're going to start with each person with respect to experience. We're going to grab the priority value for experience. We're going to put that in our graph here in between experience and the goal. And then we're going to go ahead and grab the priority values for the individuals with respect to experience and put them in the graph here at the bottom. And you can see that then there's a kind of a clear path in the graph from the alternatives through the specific criteria up to the goal. So we're going to take those values at the bottom. We're going to put them into this table right here. Astrid, Fiona, and Eep's values right there. Then we're going to grab that value of the experience right there and put that in the same value next to each one of the individuals there. And then we're just going to multiply these across. And this is going to give us the weighted value for each person with respect to the weight of the criteria, which in this case is, again, experience. We're then going to take these numbers and put them into this, which is our final table here. So I'll drop them right there. And then we would just repeat this. I did the calculations in advance here for everything right there. Then all you do is to get these final priorities, you just add these up, and then you have your final results. So we can see in this case that based on the data, Fiona is our best option to lead us. Now, if you follow HP by the book, you're supposed to actually collect these numbers via a survey, so the responses are not influenced by others. Now, when we used HP to make technical decisions with my teams at Comcast, we've taken a different approach. So it's based on the same way that we estimate our user stories. So we'd actually all throw out a number at the same time. And then if there are different numbers, we would go ahead and discuss those. And the team found that these discussions were even more valuable than the calculations that the tool did. So before I press that button to spit out our final decision on what JavaScript framework we were going to switch to, my group, we already knew what the answer would be, or should be at least, based on our discussions. And if the tool didn't spit out that answer that we were expecting, then we'd probably just ignore the tool and go with what our gut feeling was at that time. But so far, every time we've actually used AHP and gone through this exercise, our gut feeling lined up with the tool's answer. So I mentioned we did use a tool to give us the answer to our AHP calculations. So I'll show you what that looks like real quick. So basically, after you enter in all that data into the matrix, here's an example of what our weights looked like, what the tool gave us. It's a nice visualization that shows you that basically when we were picking our JS framework, community, performance were the most important ones, followed by developer productivity. And then our other things that we considered were not as important. And then for our decision, I'm not getting details of what the actual frameworks were we were choosing, because that's not important to you. But the nice thing is here with the tool, you can see that basically how the weights of the different criteria impacted the actual final decision here. So what I've labeled here is option 1. You can see how each of the different items above kind of influenced that. And then if you actually go ahead and try to generate these own graphs with your own decisions, this is actually open sourced, so feel free to go to this URL and check it out and give it a shot. The UX is not the best, but basically it does give you these nice charts. So we're going to continue to work on this, but it's available now for you to use to actually go ahead and make these calculations. So now I want to do a retrospective on HP, just kind of wrap things up. So what I'm going to talk about really can apply to any decision-making framework. So if you have something else that you use that's working well, then feel free to kind of apply the same retrospective to that. But like I've said, this has been working well for us. So like any other retro, I'm going to talk about kind of what went well and then what needs some improvement. So as far as what went well, clearly multiple things, otherwise I wouldn't have spent the time to talk to you about it. But basically, the most notable thing is many teams at Comcast have found it useful. My team's used it many times. I've told other teams about it. They've used it. And every time I've told someone about this tool, I've said, hey, please let me know if it works or doesn't. Because if it doesn't, I want to know. And everyone has said, no, actually, this was great. It was really helpful and helped us to make a decision. The other useful aspect of this is that it's a very useful piece of documentation if your team puts together architecture decision records, or ADRs. So having those HP charts and perhaps some notes that came with out of the discussions helps to give a full record of the motivation behind why a decision was made. So when I get asked about a decision that we actually went through the HP process with, I always point them to our ADR with our decision with the HP chart. And I say, here's the process we went through. Here's how we got to this decision. But don't blindly adopt the thing that we did. Please go through the same process, and then you can see what's best for your specific team. Now, of course, nothing's perfect, and HP is, and specifically the way that we used it is no different. So basically, after we used HP a few times, there was a decision that was going to be a very big decision for our group. So I was asked to help lead this big decision. It was going to have some people, we knew some people were going to be upset about the decision, but people are going to lose their job or anything like that. But just it was a very kind of sensitive decision that we need to make this. So I was asked to go through the process, and I went through the process with the team that was charged with making it. But we made a couple adjustments that turned out to cause more problems than reduce them. So one was when we announced the decision, we didn't share the input and the final charts. The reason for this was basically our leadership was saying, let's make this decision and then just move on. We didn't want to continue to debate it, which was why they thought, hey, let's go ahead and not share that. But this actually upset people more and led to more discussions. It would have been much easier just to actually share all the details up front. And looking back, the reason why this played out the way it did is because of a concept called nemawashi. And this is actually known very well in Japan. It's actually, the term is based on Japanese gardening. It's a special technique of uncovering the roots when you transplant a tree. But in business, this is a way of building consensus openly and not forcing consensus. And this is incredibly powerful when it comes to getting buy-in for your decisions. So the way it works is you start with a concept, a problem statement, an idea. And then you identify groups of people that you want to target in pre-conversation. So these are deciders that have the power to drive or enforce decision, the makers that will actually do the work once you have come up with your idea and your decision there, people that might block the idea, and those are going to be affected by it. And then in those conversations, the objective is to inform, gather feedback, and then improve the idea with the goal of making the idea better for everyone. These conversations can be very open and transparent, but most of the time it's some mix of informal private discussions and open ones depending on who is actually involved. And the key is you're not trying to change people's minds forcibly. Now this cycle continues until everyone is in agreement, and that leads to a meeting where basically the idea is presented. And since everyone was involved in these pre-conversations, it's basically a low-stress meeting. Everyone nods their heads in agreement, and the work moves on. And this maps really well to AHP. So the idea stage for the goal is the goal in our AHP graph. We then identify who will participate in the AHP evaluations and whose opinions we need to make sure are accurately represented in those discussions. Then the conversations and information gathering is the AHP pairwise comparison process. And then you have your decision, which is just hitting that button on the AHP calculations. So to conclude this part of the retrospective, be sure to learn from our mistakes. So AHP, or any process for that matter, does not make hard decisions less painful for those affected by them. You really need to have empathy for those impacted. And again, do not hide the data. This hurts the effectiveness of the decision and does not save time or help the team move forward. Instead, it just leads to more time spent on the issue. So that's all I have for today. Thank you for your time. I hope you found this useful and actionable. If you have any comments, questions, or feedback, I'm John Riv on the internet. And once again, thank you and enjoy the rest of the conference.
Hey, everybody, welcome back. Thank you, John. Every single time I hear you speak, I learn something new, and it's just always wonderful and insightful. And I think our audience felt the same way. We have a couple questions for you. So our first question started with a statement that they loved the example use case to help explain the analytic hierarchy process, or AHP. And you mentioned that no more than 8 people contributing to the analysis. So is there a recommended minimum to make sure there's an adequate amount of input?
Cool. Yeah, thanks for that question, because now I realize I need to clarify something there. So yeah, so basically the 8 number there is for the actual number of criteria and the number of alternatives you have. So there shouldn't have any more than 8 of those, because if you can picture that matrix there, that can get very, very large, and you'd be spending days and days and days doing that evaluation. The first time we used this, I believe it was that example I gave. So there were 7 criteria and we had 3 options, and that took 4 or 5 hours. So if you imagine if you had 8 and 8, there were weeks, probably lots and lots of thinking and talking there. But the number of people, it's not limited in that case. You like I talked about at the end of the talk there with Nemawashi, like, you want to be able, you definitely want to get feedback from as many people as possible. Anyone that's somewhat related there should be able to provide input to that. And then the number of people that are actually, in the room giving their opinion, that's kind of going to be based on whatever works best for your team. I think we had close to 8, it just happened to be, but there's no right or wrong answer for that. So just what kind of feels right for that group. Making sure that you do get everybody's opinion in advance so that you can funnel that into the full evaluation.
Thank you for that. And I don't know if anybody else did, but when you were talking about Nemawashi and how it's about clearing the roots of a tree, I totally had some Karate Kid flashbacks. So thank you for that. So our second question is, how does the diversity of the team, diversity meaning the full breadth of background, skill sets, engineering levels, and, personal diversity. How does that diversity of the team impact the effectiveness of AHP outcomes?
Sure. So I'm sure my answer will be no surprise. The more diverse, the better. That's it's clear. You live it, you know it. In that study about the wisdom of the crowds, it basically said, if you take a diverse group, that's going to be better than an expert in the case. So I mean, the more diverse from all levels that you mentioned there is going to be critical. And it's essential to do that and do that work again up front to make sure that you get those diverse opinions so that you're not, coming up with a decision that represents, a certain specific part of the group and not the whole group there. I talked about how, like when we went to this decision, we knew that we had one that was really big and we were not going to make everybody happy. That was very clear. But we needed to make sure that everybody was heard going into that. So at least then when they saw the decision, they knew that, hey, my opinion was in there. So again, not everyone was happy, but they all felt that they were heard. So that's critical for this to be successful because this tool, like any other tool, if you don't use it properly, it's not going to be effective. But yeah, definitely with this tool, or really any decision-making tool, diversity of opinion is going to be critical in all levels of diversity there.
I couldn't agree more. It's, driving consensus is one of the hardest things that we do. And nobody's always happy. It's, even a microcosm of like, what's for dinner, right? But maybe if you just sprinkle a little cheese on top, everybody's happy with that. As long as you're not lactose intolerant. I don't know. I love cheese. John, I was curious, do you think you'll be able to join us for the networking session?
Yes, absolutely. I'm always happy to talk to people. So yeah, if we get matched up, looking forward to talk to whoever's there.
Awesome. Thank you for that. Thank you for being here today. Thank you as always for all of the wisdom that you share with people. And, going back to what Audrey said in her talk before yours, that's really what this is all about, is not keeping secrets, not hoarding all of the special sauce, and making a bunch of new John Riviellos so that you can move on and be a bigger and better John Riviello.
Absolutely. I want to move on. I want everybody else to be where I am quicker than I got there. So I definitely appreciate that too, Leslie. Thank you so much.
Awesome. Well, thank you again.